Okay, so let's start our today lecture, which is range of length. So in our previous lecture, we studied that we have two types of object in this physical world. One is called the microscopic object, other is called the macroscopic object. At microscopic level, we are dealing with the size of atoms, molecules, and even the particle present inside the atoms or inside the molecules, which are called the subatomic particles. So our concern is to find out their size. Our concern is to find out their masses. So at microscopic level, it is very difficult to find out the size of the atom, the size of the molecule. In our previous lecture, we studied that we can find out the size of the molecule with the help of an instrument which is called scanning tunneling microscope, STM. So with the help of STM, we can find out the size at the atomic and molecular level. And even there are certain experiments by which we can find out the size of the molecules. In our yesterday video, I shared one chemical method by which we can find out the size of the molecules. The second part, the physical quantities which are of very large size at macroscopic level. Suppose we want to find out the diameter of the moon, the diameter of the sun, the diameter of the earth. So at macroscopic level, we have certain tools. I shared with you in my yesterday video. With the help of parallax method, we can find out the diameter of the moon. Even we can find out the diameter of any star. So that is a very simple method and very easy to perform. Now it means in our physical world, we have a range of length starting from the molecular level up to the size of the universe. So that is our today topic in which we will share range of length. We have range of length starting from the molecular level up to the size of the universe. So let us go for that. Range of length, the size of object we come across in this physical world, they have the range 10 raised to the power minus 14 meter to 10 raised to the power 26 meter. 10 raised to the power minus 14 meter, that is the size of the nucleus inside the atom. 10 raised to the power 26 meter, that is the size of a body similar to the size of the universe, or 10 raised to the power 26 meter, it may be the size of the universe or size of any galaxy, very big galaxy. So it means we need to measure, we need to do the experiment starting from very small length to the such big length. The range is 10 raised to the power minus 14 meter to the 10 raised to the power 26 meter, means the size of the nucleus to the size of the universe. Size of the nucleus, which is 10 raised to the power minus 14 meter, to the size of the universe. So this is our range of length. Likewise, in our coming lectures, we will study the range of mass. Range of mass. In the range of mass, we will follow the same concept from the microscopic level to the macroscopic level, from the microscopic mass to the macroscopic mass. Microscopic mass means the mass of the electron, and the macroscopic mass means the mass of the whole universe. And similar concept we will do with the time also, means the minimum time which any physical quantity perform in this universe. मिनिमम टाइम के बीच में मतलब कोई कोई भी पार्टिकल है, वो कितने टाइम के अंदर जंप करता होगा, अपनी पोजीशन चेंज करता होगा, कितने टाइम के अंदर वो डिके होता होगा, कितने टाइम के अंदर वो कोई भी फिजिकल प्रोसेस, केमिकल प्रोसेस, न्यूक्लियर प्रोसेस और एनी प्रोसेस फॉलो करता होगा. मिनिमम टाइम, कम से कम कितना टाइम लगता होगा, और मैक्सिमम टाइम कितना होगा किसी चीज को, इस पूरे यूनिवर्स को फॉर्म होने में मैक्सिमम टाइम कितना लगा होगा. सो हमारे पास रेंज ऑफ लेंथ है, हमारे पास रेंज ऑफ मास है, हमारे पास रेंज ऑफ टाइम है. So in our today lecture we are concerned with the range of length, which is from the microscopic level to the macroscopic level. Microscopic level means the length of the nucleus, and macroscopic level means the size of the length of the universe. And apart from this, we will use certain other lengths. I'm just going to discuss within a 5 minute. So I have first term which is called 1 Fermi. 1 Fermi is also a measurement of length. So what is that length? 1 Fermi is that length which is equal to 10 raised to the power minus 15 meter. 1 Fermi is that length which is equal to 10 raised to the power minus 15 meter. And this 10 raised to the power minus 15 meter or 10 raised to the power minus 14 meter, it is the size of the nucleus present in the atom. What is 1 angstrom? 1 angstrom is that much length which is equal to 10 raised to the power minus 10 meter. What is this 10 raised to the power minus 10 meter? It is the size of the atom. 1 Fermi is the size of the nucleus. 1 angstrom, it is the size of the atom. Now, 1 astronomical unit. This is another unit by which we can measure the long distances. So these two length, they are quite small length. They are at the microscopic level. So they are called the microscopic length. Microscopic length. Now, when we deal with the macroscopic objects, big size object, and then we are interested in finding the length or the distance of one object from the other object, then there is a very important term used which is called the astronomical unit. So what is this astronomical unit? Astronomical unit is, it is average distance of the sun from the earth. Average distance, it's not a simple distance, it is average distance of the sun from the earth. You know that earth is revolving around the sun in the elliptical orbit, and in the elliptical orbit, sun is at the focus of the ellipse. It is not at the center of the ellipse, not like the circle. It is at the focus, and focus is not exactly at the center of the ellipse. It is either in the left side or in the right side of the ellipse. So sun is at the focus. So that's why if sun is at the focus, and you know that there are two positions of the earth. One is called the Aphelion, which is observed in the month of July, and other is called Perihelion, which is observed in the month of January. So when it is the month of July and we are considering Aphelion, then the distance of earth from the sun, that is 152.1 million kilometer. 152.1 million kilometer. And when we are in the month of January, we are observing perihelion, then the distance of earth from the sun, it is 147.1 million kilometer. It means in these 2 months, July and January, the distance of earth from the sun is different. Because distance of earth from the sun is different, so that's why we will take average of these two distances. Average of these two distances. I am having some good notes for you, handwritten by me, so I will show you in my next slide. So one astronomical unit that comes out to be 1.496 into 10 raised to the power 11 meter. And there is another term which is 1 light year. 1 light year, it is 9.46 into 10 raised to the power minus 15 meter. 10 raised to the power 15 meter, it is a very large distance. distance that light travel in 1 year. In 1 year, the total distance traveled by light, it is 9.46 into 10 raised to the power 15 meters. So that's why it is called 1 light year. Distance traveled by light within a year is called 1 light year. And how much distance light travel in 1 year? It is 9.46 into 10 raised to the power 15 meter. And we also know that what is the velocity of light? Velocity of light is 3 into 10 raised to the power 8 meter per second. So it is the highest speed in our physical world attained by any particle. So light is made up of photons. So photons, they travel with a velocity of 3 into 10 raised to the power 8 meter per second. There is no any other particle in our physical world which can move with such an enormous speed. It is the highest speed observed in our universe by the photons. So with such a speed, in 1 year, the photons, they travel a distance 9.46 into 10 raised to the power 15 meter. So 10 raised to the power 15, it is a quite long distance. So this is a macroscopic distance. Again, this is 10 raised to the power 11 meter. Again, 10 raised to the power 11 meter. It is at a macroscopic distance. It is a quite long distance. Another term, it is 1 parsec. So what is 1 parsec? Now try to understand this 1 parsec. It is again a distance. 3, and how much distance is 1 parsec? 3.08 into 10 raised to the power 16 meter. So definition is quite difficult, but with the help of one derivation, we will try to understand the definition. So parsec is the distance. It is again a distance at which average radius of the Earth's orbit subtend at an angle of 1 arc per second. It is the distance at which average radius means at least we have two radius. One radius means distance of earth from the sun when it is at the aphelion. This is one radius. And another radius when the distance of earth from the sun and it is perihelion. Perihelion in the month of January, aphelion in the month of July. So we have these two radius. We can take them R1 and R2. So we will take the average of these two radius. So let us go to the next slide, and my next slide that will clear you how to derive one astronomical unit, average distance of sun from the earth, which is 1.496 into 10 raised to the power 11 meter, and 1 parsec, which is equal to 3.08 into 10 to the power 16 meter. So let us go to my next slide. So in this slide, you can see first I will go to the left part of this slide. One astronomical unit, which is represented as 1 capital A dot U, one astronomical unit. So it is average distance of the sun from earth, average distance. So let me take the elliptical orbit of our solar system. Earth is revolving around the sun. So this is an ellipse, and this is the semi-major axis of the ellipse. Major axis of the ellipse. Sun is not exactly at the center of the ellipse. Sun is at the foci of the ellipse. So this is called the focus of the uh, ellipse. So in the solar system, like Earth, other planets, they are also orbiting, they are also revolving around the sun. The sun is at this position, and the orbits are elliptical orbits. So these are our elliptical orbits. I have shown the elliptical orbit of the Earth. So now, if sun is at the focus and we are in the month of January, so we are observing perihelion. So this is our Earth. So take this distance as R1. Take this as the radius. Take this as the radius because this is a ellipse. So we will take the radius R1, R1. And when we are observing the month of July, means we are observing aphelion. So radius of Earth is R2. So we have two different radius, R1 and R2. So very clearly you can see R2 is greater than R1. Now we are interested in how much is R1 and how much is R2. R1, exactly, R1 is equal to 147.1 million kilometer. R1 is equal to 147.1 million kilometer. This is the exact and precise value of R1. Likewise, R2 is equal to 152.1 million kilometer. Million means 10 raised to the power 6. So our definition is average distance of the sun from the earth. So we will take because we are interested in deriving one astronomical unit, so I will take average of these two radius. So I will take R1 plus R2 divided by 2, that will give me one astronomical unit. R1 plus R2 divided by 2. Average of these two distances. Average of these two radius will give me one astronomical unit. So one astronomical unit, now place the value of R1, which is 147.1 million, means 10 raised to the power 6 kilometer. 1 million is 10 raised to the power 6 kilometer. It is 10 lakh. It is 10 lakh. Plus place the value of R2, it is 152.1 into 10 raised to the power 6 kilometer and divided by 2. Now 147.1 plus, sorry, this is no this is plus 152.1. So you take this plus sign, I have taken wrongly this as the minus sign. Take this plus sign, this is not the multiplication, this is the addition. So now 10 raised to the power 6 into 10 raised to the power 6, that becomes 10 raised to the power 12, and you add and you divide, you will get 149.6. You add 147 plus, this is wrong, this is not multiplication, this is addition. So 147.1 plus 152.1 divided by 2, we will get 149.6. Multiply 10 to power 12, because when bases are same, then power are added. Base is 10 over here, base is 10 over here, then both the powers, they will be added. So we will get 10 raised to the power 12, and it is in kilometer. Now, one astronomical unit, now when we replace the point 1496, it becomes divided by 10, and 10 raised to the power 12, 10 is cancelled. So this becomes 10 raised to the power 11. And 1496 into 10 raised to the power 11 kilometer. But we are interested in meter, because distances in SI unit, they are measured in meter, not in kilometer. So finally, when this kilometer is converted into meter, then we get to 1.496 into 10 to power 11 meter. This, if we take the round figure, then it can be written as 1.5 into 10 raised to power 11 meter. So how to define one astronomical unit? One astronomical unit, that is 1.5 into 10 raised to the power 11 meter. Okay, so it is the average distance of the sun from the earth. So focus on this diagram. Take the two radius of the earth, one at perihelion, which is R1, one at aphelion, it is R2. Perihelion, it is in the month of January. Aphelion, it is in the month of July. So take the average of these two radius, take the average of these two distances, we will get one astronomical unit, which is 1.5 into 10 raised to the power 11 meter. Now, again, focus on this diagram. So it means, because it is the average of these two radius, one astronomical unit, it is average of these two radius. So it means I can take R1 nearly equal to one astronomical unit. R1 nearly equal to, exactly it is not one astronomical unit, because one astronomical unit, it is the average of R1 and R2, but I can take R1 nearly equal to one astronomical unit, R2 again nearly equal to one astronomical unit. Exact astronomical unit, it is the average of these two, R1 plus R2 divided by 2. But uh, it can be taken as nearly equal to 1 astronomical unit. Why I am taking? Because in our next derivation, next solution of 1 parsec, I will take this concept r1 nearly equal to 1 astronomical unit, or r2 nearly equal to 1 astronomical unit. So let me go to the second part, which is 1 parsec, and 1 parsec is equal to 3.08 into 10 raised to the power 16 meter. This is again a distance. So which type of distance is this? So it is a distance at which average radius of the earth. Again, we will take average radius of the earth orbit, earth orbit means earth is orbiting around the sun in a particular orbit. So take the average of that. Earth is orbiting around the sun in a particular orbit, so we will take the average orbit. So average radius of earth's orbit, subtend an angle of 1 arc second, and 1 arc second is 1 upon 3600, 1 upon 3600 multiply pi upon 180. So the definition will be clear after the this solution. So take the earth orbit as the elliptical orbit, and already we have two position of the earth. One is the uh, aphelion, which is observed in the month of July. Other is the perihelion, which is observed in the month of January. So take any of the position of the earth. That is our choice. That is our choice. So I am taking here the month of January, and the position of earth is perihelion. So perihelion, now I can take this distance, this radius r1 nearly equal to 1 astronomical unit. 1 astronomical unit. So I take such an height from the sun. I take such an height from the sun where Earth's orbit subtend an angle of alpha. I take such an height from the sun, such an height from the sun, so that the Earth orbit, so that because Earth orbit is a curve orbit, so we will place the Earth at that point where this angle become 1 arc second, where the angle become 1 arc second. This angle will decide this height. This angle will decide this height. So angle is fixed. This 1 astronomical is also fixed. 1 astronomical is also fixed. So we will fix this angle, which is 1 arc radius. It is a very small angle, very small angle. So we will get this height. This height, this perpendicular distance, this vertical distance, that will be 1 parsec. Now, this angle is alpha is known, and this 1 astronomical unit is also known. So we can calculate for tangent alpha. So tangent alpha is equal to r1 upon 1 parsec, because angle is very small. It is 1 upon 3600, 1 arc per second. So this is 1 arc pi upon 180, and this is per second. So 1 upon 3600. 1 arc is pi upon 180, and per second it is 1 upon 3600. So 1 arc second, this become 1 arc second. So it is very small. So we can replace tan alpha by alpha, because tan alpha, that may be a big angle, and our actual angle is a very small angle. So tan alpha, that is replaced by the small angle alpha. So alpha is equal to r1 upon 1 parsec. So alpha is equal to r1 is exact. It is 1 astronomical unit. Already in the left notes you can see r1 nearly equal to 1 astronomical unit if we are taking perihelion. But if we are taking aphelion, then we will take r2. So in that situation, the hypotenuse that will be drawn from aphelion, and again the perpendicular height that will be taken from the sun. We will do the same procedure for the aphelion also. I am solving for perihelion. So alpha is equal to 1 astronomical unit divided by 1 parsec. Already we know that 1 astronomical unit is equal to 1.5 into 10 raised to the power 11 meter divided by 1 parsec. Now place the value of alpha, which is 1 upon 3600 pi upon 180 is equal to 1.5 into 10 to the power 11 meter divided by 1 parsec. And we are interested in 1 parsec. So very easily we can find out 1 parsec. So 1 parsec is equal to 1.5 into 10 to power 11 meter divided by 1 upon 3600 multiply pi upon 180. So after solving this, we will get 1 parsec is equal to 3.08 into 10 to power 16 meter. So again, now we can just discuss the definition of 1 parsec. So it is the distance at which average radius of the earth orbit subtend an angle of one arc. So we are discussing this height so that the average radius, first we will take this r1, then we will take r2, and we will take average of these two. But here I have taken separately, I have taken perihelion. So we will get the same result if I am taking perihelion or aphelion. So for perihelion I solve this. R1 was nearly equal to 1 astronomical unit. So simply we can find out 10 alpha. So by this 10 alpha, we will get the alpha because angle is very small. So alpha is equal to R1 upon 1 parsec. And we know R1 is already 1 astronomical unit, which is 1.5 into 10 to power 11 meter. So alpha is replaced by 1 upon 3600 into pi upon 180. So finally we got 1 parsec is equal to 3.08 into 10 to power 16 meter. So let me go to the backslide. And today our topic of discussion was range of length. Range of length. So in range of length, the range was from the microscopic level to the macroscopic level, from the size of the nucleus to the size of the universe. So we find these very small length to these very small length. One is the 10 to power minus 15 meter, which is the size of the nucleus, and other is 10 to power minus 10 meter, which is the size of the atom. So these length, they are at the microscopic scale. And to find this length, we have to take the help of special instruments. I told you in my yesterday video, we can take the help of scanning tunneling microscope. Even with the help of some chemical method, we can find out these length, these size. The second we discussed quite large distance, means distance at the macroscopic level, distance at the universe level. So the first term was 1 astronomical unit, and we just solved 1 astronomical unit, and that is 1.496 into 10 raised to the power 11 meter, which is quite big in size, which is a very large distance. And in round figure, we take this 1.5 into 10 to power 11 meter. Then we discussed 1 light year, and 1 light year, it was the distance traveled by light in 1 year, because the speed of light is the highest speed with which anything in this physical world can move. There is no any other particle, there is no any other object who can attain this such high enormous speed. Only the photons present in the light, they have the capacity, they have the energy to acquire this speed. This is the highest speed. That's why this is called a speed constant. This speed is constant. This is fixed. If photon in the thousands year back they were moving with any speed, then that speed definitely it was 3 into 10 raised to power 8 meter. Right now the speed of the photon is again 3 into 10 to power 8 meter per second. The photon coming from the sun, or the photon coming from the bulb, or any light emitting object, if it is emitting the light, it is, if it is emitting the photons, then the photons they will move with such a high speed. So this is also called the electromagnetic speed. Electromagnetic speed. And in the future also, the photons, any light source that will emit the photons, and the photons they will move with the same speed, 3 into 10 raised to power 8 meter per second. So that is a constant. 1,000 year back it was same, right now it is again the same, and in the future it will again remain the same. Then we discussed the next term, 1 parsec. 1 parsec, again, it is a very large distance. Large distance means it is actually the height above the sun. It is height above the sun when Earth subtend an angle. Earth orbit subtend an angle of 1 arc second. It is the height exactly above the sun when Earth orbit subtend an angle of 1 arc second. And 1 arc second is 1 arc pi upon 180, and 1 second is 1 upon 3600. So this is 1 parsec. So with this, I just summarize. I close my today lecture, and in the next lecture we will move with our further slides. Okay, thank you.
Thank you, sir.
So
Thank you, sir.
let me take the attendance.
Thank you,
Uh,
sir.
Ayush Dhiman, Suhani Thapa, Manoj Thapa,
Present, sir.
Manoj Thapa, Payal Chauhan,
Yes, sir.
Manoj Thapa, Manoj.
Yes, sir.
Manoj, this is your first lecture.
Yes, sir.
Why you are absent?
सर थोड़ी प्रॉब्लम चल रही थी.
छोड़ दो प्रॉब्लम को और लेक्चर में रेगुलर रहो, ठीक है?
ओके सर.
वैभव,
Yes, sir.
वैभव कोहली,
Yes, sir.
वंश, वंश, वंश,
Yes, sir.
वंश. There is another Vansh. Vansh. First is Vansh Moria. Second is Vansh Bijalwan.
Yes, sir.
Vansh Moria. Moriya. And Vansh Bijalwan. Shefali Dhiman.
Yes, sir.
Shefali Dhiman. Many students, they are not regular. So please be regular. Today I have the
Yes,
highest
sir.
strength of 8 students. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's all for today.
Thank you, sir.
Okay,
Thank you,
Thank
sir.
you, sir.
okay.
Thank you, sir.
Okay,
Bye, sir.
bye.